video of fluid mechanics. First lesson. Okay, anyway. So this video comprises of all those things in lesson 1. So I'll just try to cover up all those things within a few videos. And these are the subtopics that I want to go through. So just without further ado, let's start off with what fluid forces comprises of, or what are the things that are inside there. That we are studying in lesson 1 are density, fluid forces, pressure, stress, and viscosity. So mainly I think I'll just cover this video, I'll just cover this portion over here. If can have time, then I'll just cover this. So yeah. So let's start off with the slides. You can just read it out. This is just an introduction. And then density, is rho equals to mv, that's all. Make sure you know the SI unit. And then fluid forces, it has force equals to ma, where this is the mf in this case. So the f itself is the so-called the acceleration of the fluid. Okay, so instead of a is just f, so it should be the acceleration of the fluid itself, and the mass accelerates with acceleration. So the mass of the fluid is accelerated. So that's the meaning. And then you have body force and surface force. And then body force comprises of W equals to mg, and then surface force is a little complicated. It comprises of the pressure equals to force over area. The force is the normal force on the plate. So when you apply the pressure normal to the plate itself, you'll have some surface force. And then another type of force is actually a shear stress, which we're gonna talk about it a lot. So tau is actually the stress itself. It's just a symbol for stress, and it's equals to F over A also. And in fact, it's a little different from pressure. Pressure is the normal force, rather than the fluid. For this force now is the force that is parallel to the plate itself. So it's actually the shear stress. Okay, it's trying to pull. There will be a force trying to push this plate this direction. So let's say maybe I can start a new page. So let's say if you have hold on. Okay, so imagine you have a plate over here. Okay, this black color is the plate, and this is the water, and this is the ground. Okay, so imagine you have a plate on the water itself. Okay, and then when you apply the force, okay, let's do it in red. So if you apply the force in this direction, when you push this plate in towards the green position, this green position is the position where after I push the black color. Okay, so the green position is after I push the black color. So in other words, the black color moved into this green color spot. So when you push it in this manner, the fluid will actually follow the plate itself, the surface of the plate over here, right? So when you push it, the fluid at this portion, the velocity of the fluid itself is much faster than slightly lower than it, and then slightly lower than it. So I think you understand what I mean. So you just push it down, and then this will actually follow, because this is nearest to this. There will be a friction, or somewhat it stick to it. So it moves with a very fast speed, and then subsequently for the lower height. Okay, let's call it height h. So for the lower height at this point, the speed itself is lower than the speed over here. So I'm just trying to convey this thing. So hold on. And then while the pressure itself, as I say earlier, the pressure is just a force pressing down on the plate perpendicular. So that is all. And then to a clearer view, fluid forces comprise of body force, which as I say is W equals to mg. Okay, body force is just the weight of the fluid itself, that's all. And then it also comprises of surfaces force, which I said just now, the pressure and the shear stress, which is the pressure, the normal force, normal perpendicular to it, and the shear and the tangential force, which is parallel to the plate itself. So this is the shear stress. So shear stress can be further evaluated in terms of viscosity, and we will be discussing a lot of things on here. So yeah. So the pressure itself as we described over here okay. Maybe hold on a while. So I think nothing much, it's just 1 bar equals to 10 over 5. I mean 10 to the power 5. And pressure and stress we have just discussed. So it's nothing much. And then now we talk about viscosity, which is just now the graph itself. Okay, shear stress, pressure, and then viscosity. Now we talk about viscosity. So what is the thing that reacts with viscosity is just that it is layer by layer. So each layer of this fluid, as you can see, they are moving in this motion. Okay, so this is later we will discuss is a non-uniform flow. So one faster is let's say you have this fluid over here, which is the fastest. So this fastest one will drag the slower one. Okay, so it start to drag. If you have fluid, like if you have a water pressure on this side, then it start to spray in this direction. Okay, in this direction, a lot of force is in the middle of the pipe, right? So a lot of force in the middle of the pipe, is starting to pull all this fluid, you know. But the nearest from this place, right, from this is slowest, is because there is a friction against the surface of the interior surface of the pipe. So this friction will stop this fluid from flowing, and then therefore this one will also stop this from flowing. So it's a little that type of manner, okay. And so if you were to think of honey itself, honey, the flowing of the honey is is um is at first like that, right, one piece, and then it start to flow down, and then part of it start to flow down over here, and then start to flow down, and then start to flow down like that, right? So this is how it flow layer by layer. That's what it means. Just that you need to know the frictional, the one that is nearest to the surface, and then that the shear stress. Just now, as we discussed, the shear stress is a result of the viscosity of the fluid itself. Okay, so the shear stress is due to this shearing of the fluid within the fluid. So as you can see, when the fluid is being chong in this direction, the fluid is against this this surface of the pipe. So there is a certain tangential forces that start to pull this fluid down. So if you were to imagine it's the fluid like that, and then this is the pipe the pipe surface, and then you have a water fluid, and then the water fluid is being sheared in this manner, you see. So the friction force in this direction, and then the fluid is going in this direction, so there will be a shear force in there. So this is what it means. And then viscosity is also a property of fluid which determines the amount of the resistance to a shear force. Maybe you can remember this definition. And then yeah, so I'll just end this video. So next video we'll talk about shear stress and force concept, because we are 8 minutes already. So yeah.